Okay, so our chapter was 4.1, and it's scatterplots and correlation. We'll start off by going through scatterplots first, and to begin, scatterplots is the most effective way to display the relationships between two quantitative variables, and you have to make sure that your two variables are quantitative and not qualitative, because you obviously can't use non-numerical values in order to plot a graph. And so this right here is our first scatter plot, and on the x bar region right here it shows the explanatory variables, and explanatory variables are always on the x and response variables are always on the y. And so right here is a pretty good strong correlation, and you can see that it's going in a positive association, and it's around 0.8 right here. And to make sure, you know, scatter plots range from -1 to 1, and so you can determine their value by looking at the graph and kind of putting an estimate around it. And this right here shows you a outlier, and when you're looking at a scatter plot, you always want to look for outliers because they really affect the curve and the relationship between the numerical values. Right here is the outlier, and this is a pretty strong positive correlation between, let's say, around 0.7 to 0.8. These right here are clusters, and this is, I guess, like the graph that the calculator graphed it for us, and it's showing us the association and the most likely output that the points they've calculated, and this is the line that is basically the ultimate value. And right here there are two main clusters, and there aren't any outliers, so there you go. And to give you some correlations examples, this right here is very strong, and it's close to 1. This right here is around 0.8. This is 0. This is no correlation. And this is moderately negative, so around -0.8. This is around -1. And this right here is a curved relationship. It has some negatives and some positives, and it shows you that it's nonlinear. Okay. So as we move to correlation, correlation has really one big formula, and this is it right here. So you describe R as the correlation, and you have to make sure again that it's two quantitative variables. No, we don't need these.
Okay.
And so you begin by 1 divided by n-1, n being the amount of individuals, and this right here is a sum of symbol. There's x, you subtract it from the mean of x, and then you get the standard deviation of x, and then you multiply that by the y, and then the mean of y, and then this divided by the standard deviation of y. And so basically you use PEMDAS in order to do the order of the calculations, and then you'll find the correlation, which is R. And really, correlation requires that both variables are, again, quantitative, and there are two main associations, positive and negative, and you will be able to calculate that after you find the answer to R. And on the previous slides, I showed you the strong association between 1 and -1, and from that you'll be able to distinguish which are positive, which is negative, and you'll be able to use a rough estimate of what value it is. So that's scatter plots and correlation. Okay, so to do an example problem of correlation, since correlation measures the direction and strength of the linear relationship, we have the formula right here, and so basically these are the students. We have 10 students, and this is the X number of hours they study, and this is Y, the exam scores that they received. Okay, so basically we're trying to find this correlation between if they they study X amount of hours, do they benefit from studying those hours? And do their grades improve as they study more? And this XY right here, it's basically a convenient little part. Since you multiply X and Y in the end, they just did it for us ahead of time, so it shows you right there. So as we go down, we can see that it is worked out, and it shows you right here its formula. It might look different. That's just putting it in a different way, but it's still the same formula. Okay, so this is the part where they plug in the numbers. So right here is the total number of students, and you subtract it with 1. That was n right here. And they found the sum of x and y, and right here. So they basically did x minus the mean, which is right here, and then the y minus the y mean, and then they found both the standard deviation of x and y, which is 2.1628 and 11.5706. And then so basically, as you calculate it all out, you'll eventually end up getting 0.8156 or 0.82. And there you go. That's a correlation problem.